In this video, we are going to build conceptual explanations for two very important divisibility rules: divisibility by 4 and divisibility by 9. Let's begin with divisibility by 4. Suppose we take a 100 block and we want to divide it into 4 equal pieces. And we want to know how many are left over. Well, if I break this here as well as here, then I have exactly 4 equal pieces, and there is 0 left over. This is pretty easily seen by the fact that 100 divided by 4 is equal to 25, with no remainder. This means 100 is divisible by 4. Now think about any number written in base 10. A number like 3,724. This is 3 thousands plus 7 hundreds plus 2 tens plus 4 ones. But the thousands and the hundreds are both built from hundreds. And since 100 is divisible by 4, any number of hundreds is divisible by 4. Also, 1,000 is divisible by 4 since it's 10 hundreds. So the thousands part and the hundreds part do not affect whether the whole number is divisible by 4. We know this is divisible by 4. And we know this is divisible by 4. So we only have to check the last 2 digits. 24. And 24 is divisible by 4. So 3,724 is divisible by 4. This is why the divisibility rule for 4 works. A number is divisible by 4 if the last 2 digits are divisible by 4. Because the hundreds are always divisible by 4, and the thousands are always divisible by 4, the 10,000s, the 100,000s, etc. Those parts are always divisible by 4. So we only need to check those last 2 digits. Now, let's move to divisibility by 9. First, I want to divide a 100 block into 9 equal pieces and see how many are left over. Well, I can do that by actually putting 11 blocks into each group. So here's a group of 11. My next one, we have this group of 11. So that's 2. And I can kind of continue this pattern down. Here's a third group. A fourth group. A fifth group. We then have a sixth, a seventh, an eighth, and then finally we have our ninth group. And this time we actually do have 1 left over. And that's going to be important. 100 is 99 plus 1. Since 100 is 99 plus 1 and 99 is divisible by 9, there is 1 left over. If we had a 10 block instead, there would still be 1 left over. For the exact same reason, 10 is 9 plus 1. This is very important. A 100 leaves a remainder of 1 when divided by 9. A 10 also leaves a remainder of 1 when divided by 9. And of course, a 1 leaves a remainder of 1 when divided by 9. So let's look at a number like 572. This means 5 hundreds plus 7 tens plus 2 ones. When dividing by 9, each 100 contributes a remainder of 1. So when I divide 5 hundreds by 9, I will have 5 ones as my remainder. Each 10 contributes a remainder of 1. So when I divide by 7 tens by 9, I will have 7 left over. Each 1 contributes a remainder of 1. So I have an extra 2 as my remainder. When I add these up, I get 14. That means 572 has the same remainder when divided by 9 as 14 does. And 14 has the same remainder of 1 plus 4, which is 5. So 572 is not divisible by 9. But if the sum of the digits is divisible by 9, then the original number is divisible by 9. This is why the divisibility rule for 9 is that we add the digits to see whether the sum is divisible by 9. This is a beautiful place value argument. As teachers, this matters because students often see divisibility rules as tricks. But really, many of them come from the structure of our base 10 number system. And when students understand that, they are not just memorizing, they are reasoning. You are doing important work here. These explanations build the kind of mathematical understanding that supports strong teaching later. In the next video, we will practice applying divisibility rules to a set of numbers.